Good morning. Today we are working on CO47. I can identify the domain and range of a relation. Ooh, lots of new vocab words here. So let's not try working ahead. Let's just listen to what these vocab words mean so we'll be able to do the work. The relation is a collection of ordered pairs. And that can be seen in a table or in a graph. So that collection of those ordered pairs will be in a function table or it's going to be in a graph. And I'm going to show you what that means. The domain are the x values of a relation. Anyone want to make a wild guess on what the range would be? If the domain are the x values, what do you think, Claire?
Y value.
Yeah. The range is the y values of a relation. So we know with the ordered pairs, it's always x then the y. And so our x's are the domain, the y's are the range. So we're going to discuss relations in two different forms. In the table and in the graph. And we're going to write the domain and range that we get for each of those. Okay? So there's special ways that we have to write this. So we really need to pay attention. So we could have the XY table, that function table. This is the easiest one to make that domain and range. Because it tells us, right? What's our domain in this function table? Hadley. Keep going.
-5, 2, 4.
So in that function table, it tells us specific x's. You write down every single one of those x's. So for my range, it tells us our specific y's. What is the range of this function table? Christina. -3, 0, 8, 2, and -1. Easy peasy. Done. The graphs are a little more complicated. So if we look on that coordinate plane, I see this graph has arrows, and this graph has points. What do we call each of those graphs? What was graphed on the first graph? A line. A line goes on forever. So we have those arrows to show that our graph is only a small portion of that coordinate plane. It goes on and on and on and on. So if we have those arrows to show it's a line, we know it's going to keep going and keep going. What do we call this? Harper? A segment. A segment has a beginning and an end point. So it does not continue on. So it is only these parts in between those points that are in that relation. So a line goes on and on and on. We're going to write out those domains and functions one way. The segment is specific. We write it a different way. So you have to pay attention if it's a line or a segment. So let's look at our line. That line goes on and on and on. So if I want to write the domain for it, is that going to be easy to do if it keeps going on and on and on and on for infinity? No, I can't list everything. So what we do is we make this symbol right there. And that is the symbol for all real numbers. So to make it bigger, you do 2 lines, you come to this first one, and you turn it into the R. That means all real numbers. Every possible number. That line crosses all of the X's, right? We know it's at 0, 1, 2, 3, 4, 5, all on and on and on. Same with the negative numbers. It covers every number, so all real numbers. So now we look at our range of a line, and it's going to keep going down, it's going to keep going up. Again, it is going to be those all real numbers. So if it is a line that's being graphed, the domain and range is every single number possible. All real numbers. That makes sense. Our segment, though, has a beginning and an end. So its domain and range are very specific. For my domain, I'm going to pick my first X, which is -1. And I'm going to draw an arrow, and guess what my arrow is going to go to? What do you think, David?
It's going to go to 5.
Yeah, it's going to go to that ending point at 5. So following that same logic for my range, what do you think my range is starting at? Kyla?
7.
7 to what? Claire?
1.
To 1. Now you could write it 7 to 1, or you could write it 1 to 7. It's just showing that it goes between 1 and 7, 7 and 1. I would accept it either way. My brain doesn't like to go from big number down to small number. I like to go from little to big. It just makes more sense to me. It means the same thing. So I would accept it either way. Sometimes it's just easier to say from left to right, so 7 to the 1. Any questions on that? All right. So let's look. Down here it says write the domain and range of the line or segment. Remember the difference between a line that goes on forever and a segment that has endpoints. We look at those differently. So let's look at this first one. Is that a line or a segment? It's a segment. It doesn't have the arrows at the end. So we know it starts and stops. So what would my domain be? Harper.
-4.5. Or -4.
-4. And then I have my arrow, -4 to what? To 5. Then I need to write my range. Tessa.
1 to 3.
Yeah. 1 up to the 3. You're going to do the next 2 on your own. Okay? So I want you to figure out with the line, what do you put for domain and range? And then segment, what do you put for the domain and range? The next page is different. So let's look at this next page. Now, this says to make an XY table, that function table, with the given domain and range. Or make a table or a graph. So we're gonna look at it, and the first thing we have to decide is, can I make a table, which is the easier way, or do I graph it? And I'm gonna show you how we graph it. If we have very specific domain and ranges given, is it gonna be a function table or a graph? What do you think, baby? Oh, I thought you did that. Christina. Yeah, it's gonna be that table. So I'm going to make my table with my X and my Y. I need to line them up specifically, which X goes with which Y. So we know domain is the X's, range is the Y's, and we line them up. So -4 connects with 3, -1 connects with -4, 6 connects with the 6, 0 with the 10, and 2 with -1. So it is important that you line them up, the X with the Y that it goes with. Any questions on that? Okay, so anytime that you see very specific domains and ranges, we know it goes into the table. Always go straight for the table and just line them up. But now, we see a different kind of domain and range given. Because it's not all real numbers, is it going to be a line or a segment? Yeah, it's going to be the segment. If it said all real numbers, it would be a line, but we don't have any of those. So what we're going to look for is how to do a graph that segment. So you're going to make your 4 quadrants with that X and Y axis. First thing we want to do is find out what ordered pair we start with. So that segment starts at -3, 2, and it's going to end at 5, 4. So I'm going to look over here and I'm going to say, okay, -x, but a positive y is going to be here, so I'm going to say about right there. I don't have to be precise and exact, but I do need to know that if it's a -x and a positive y, it's going to be in that second quadrant. Then I have 5, 4. So I'm going to say, okay, if this was me going out to -3, going out to +5, it's about here, so about right there. It's a segment, so all I do is connect the dots. No arrows, because it's not a line. So I just connect my dots. It doesn't have to be exact, precise, but it has to make sense, right? We wouldn't say, oh, okay, like that, because this first point is at a 2, this one's at the 5, so that wouldn't make sense, okay? It has to be similar to what my answers are given. Okay, it's going up from left to right, quadrant 2 into quadrant 1. So you have to have your beginning and ending points in the correct quadrants. You have to figure out, is it going up or is it going down? Do you understand how we find our beginning points and our ending point? Okay. The first XY pair, the second XY pair, beginning, ending. Any questions? Okay, so we're gonna make sure you finish those first 2 on that first page with the graphs, and then you're gonna work on the second page. If you have questions, if you wanna just check if you're doing it correctly, you can come up and see me over at my desk for some extra help. If you have questions on practice works, now is the time to come and ask me. If you have questions on the math packet, now is the time to come and ask me. If you are watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day.